In practice, a lot of data follows the normal distribution, or you say is shaped like the normal distribution. In order to make it easier to work with, we can standardize the normal distribution. So by standardizing, I mean making the mean equal to 0 and the standard deviation equal to 1. So this makes it really simple to work with. You can do a lot of simple math to understand what's going on and estimate things under the curve. So standardizing the variable is a fairly simple process. We call it converting to z-scores. What happens when a variable is standardized is that regardless of the variable or even the underlying data itself, it's always on the same scale. So even though we're changing the actual observations from their real score to a z-score, the shape and everything else about the distribution is going to be the same. So the mean is always going to be 0 and the standard deviation will always be 1 by definition once we convert it to z-scores. So now let's take a look at how you do this with Excel. So I'll show you by calculating the individual data points to give you a basic idea of how this works, kind of like looking under the hood of a car, so we can see the mechanics behind what's going on. So first thing we need to do is get the mean. So I have a label here for the average. So calculate the mean very quickly. And then we also need to calculate the standard deviation. These are the two things that we need to know to convert to z-scores. Select the sample for the standard deviation, and again, the same data points. So here we have the mean is 11.65, and the standard deviation is 7.53, basically. So now it's time to standardize the variable. I labeled the column here standardized tenure. The variable is tenure. So this is just a way to show you that this is what the standardized values are going to be. So I'll take the first observation here, A2, and subtract from that the mean. So the mean here is in B22. Now remember, because we're going to be pulling this formula down, we're going to want to use the cash signs in order to hold this observation in place so that as we go down, it stays using the mean here. It's not going to continue to go down. Now, what we're going to do after this, after we subtract the mean, is then divide by the standard deviation. Now, standard deviation is down here in B23. So divide and then B23. So here we have the z-score for the observation of 3 is negative 1.15. So it is below the mean, so it's negative, and then it's greater than 1 standard deviation away from the mean. So 3 is more than 7 from the mean of 11.65. So now we can, if we add the cache where appropriate to keep this observation, the standard deviation one locked, we can now pull this down and calculate the z-scores for all other positions, for all the observations. So here we see 27. This is pretty far above the average of 11.65. More than 1 standard deviation above, in fact, more than 2 standard deviations above. So it's one of the more extreme values farther away from the mean. If we look at the observation 11 here, this is really close to the mean. So it's the z-score is going to be very, very low, very close to 0. So basically the z-score here, look at number 23, just over 1.5. That means it's 1.5 standard deviations from the mean. That's how we can think of it.